Confounding is one of the most important concepts in epidemiology to try to sort through associations and make our best attempt to find associations that are truly causal. Confounders tend to be a class of third variables, is what they're called. They're sort of lurking variables that are affecting our ability to look at an exposure and relate it to disease because it's also associated with the disease and the exposure. So the way that we untangle this is by starting with, in a sense, a hypothesis on what could be a confounder. So for instance, if we were looking at a particular behavior type, like type A or B, that are representing exposed and unexposed, and serum cholesterol, which is a biomarker for what's happening within the arteries, and the actual impact on the risk of coronary heart disease, we would want to be able to take the data that's collected and to look at both of these factors simultaneously. So here's the raw data in what would be sort of a 4x2 kind of setup. And we're going to go through the steps to evaluate confounding. It always starts with, for instance, the examination of the actual exposure here. So you got to make sure that you're clear on what is the exposure and what is the potential confounder. And we're going to estimate what's called the crude odds ratio. This comes from a collapsed 2x2 table. It's collapsed because we're going to take some of these cells and put them together. And you are familiar with this kind of basic 2x2 table, so don't get tripped up by the fact that all you have to do is come up and say, oh, well, type A is the class that I want to collapse, so I can actually put these cases together for this cell, and I can take these cases, 106, for that cell. There's type B here, that's 46, and here's the type B without coronary heart disease, and that's 114. So now the odds ratio is just the way that we've always calculated it. It's sort of AD over BC, if you want to remember the formula. And that translates into a crude odds of 3.69. So you could even see this in the literature. The crude odds of the association between type of behavior and coronary heart disease is 3.69. Well, what if actually that association is affected by people's cholesterol? And how would we know that? Well, the very first step is now to stratify by the confounder. So for instance, if we go back to this original table that has that data and we now stratify by the confounder, in this case serum cholesterol, what does it basically mean? It means that we're going to do two of the same kinds of 2x2 tables we just did. So this is the same heart disease, yes and no, exposure, yes and no, but we're going to do it in the two different levels, or in this case, strata is the term we typically use. So you can see we're looking at the same association that we did in the crude. We're just doing it in both of these groups. So it's just a matter of going up to this table and then filling in what these actual cells are. So for instance, this cell goes to this cell in the high cholesterol group, and I'm just going to sort of fill these in. There's 54, there's 36, and there's 72. So this one, this one, this one, and this one. So right here, we also then have the second table. So that's 50, 10, 52, 42. And if we use our basic odds ratio formula and calculate it, the odds ratio here is 4. And the odds ratio here is 4.03. So this is the very first step where we now have got to start looking at the conditions for confounding. One of the conditions for confounding is that the odds ratio in strata 1 should be the same as the odds ratio in strata 2. It doesn't have to be precisely equal. You just need to know that. I mean, so 4.0 and 4.03, they certainly are not different. But it could even be like 3.9 and 4.0. And there are actually tests for whether or not two odds ratios are the same. And in the next section of the course, we'll actually do an example of this. It's called effect modification, when these two are not the same. But that's a different kind of effect than confounding. So we're going to actually just focus on this scenario. And for this case, they're the same. Okay, so now what do you do? Well, if you remember, the whole concept of confounding comes from a triangle that indicates that the confounder, that third variable, and I'll just do this on the side here, should also be associated with the exposure in order for the effect of the confounder on disease to come back through and affect the exposure. This arrow has to be true. So now we're going to check whether or not there's an association between, in our case, cholesterol and the odds of behavior to see if that's in fact true. So going back to this same table, it's kind of amazing what you can get out of a single table. We're now going to change the actual orientation of what is being evaluated by looking at the confounder and the exposure and their association. So remember the exposure here. This is the plus and this is the minus. So now doing the collapsing in a completely different way, we find 162 individuals here and 102 individuals there and 108 individuals here and 52 individuals there. And if you have trouble kind of moving from this table to this table, just take your time and actually sort of tick off. It's like, okay, I've got type A, and I've got cholesterol high, and where am I getting this number? Well, it actually is from the totals over here. Put these two together, that's the cell right there. And if you do this for the whole group, this is exactly what you're going to get in terms of the cells for this table. Okay, so here the odds ratio is estimated exactly the same way that we've been doing it, and we come out with 0.76. In practice, we would want to do a 95% confidence interval so we could see whether or not the null hypothesis value of 1 is actually in there. If it is not in there, we have evidence that this is a significant association, or at least an association that's not by chance alone. So in this case, I'm just going to tell you, yes, this is significant. Association. And so we've got evidence that this part of the triangle is indeed holding and could be leading to an association being affected by this confounder. It's almost like this association is sneaking up into that association. All right, so now there's another leg here that we have to evaluate. And we're going to leave it actually to you guys to do, but you should also evaluate this part. Is the confounder associated with disease? It's the same actual principle that we've been using over and over again of collapsing. So at the end, you have to kind of put it all together. So does serum cholesterol appear to be a confounder of the relationship between behavior type and odds of CHD? And you're going to explain how that could be. And so one of the things to develop in your own mind is the actual kind of 3 steps that have to be true. So for instance, the confounder has to be associated with the exposure. And that's what we just did. Okay? The confounder has to be associated with your outcome. Otherwise, there's no way that an association is coming up into your exposure relationship. The other thing is that the strata-specific odds ratios have to be the same and different from the crude. So the crude here was 3.69, and relative to the strata-specific ones that we had, 4.0 and 4.03, we would call this different. And there are a couple of different ways that people do this. Some of it's just by eye, and some of it is called the 20% rule, where we'll take 20% of this and then do the actual 3.69 plus or minus that 20% of the odds ratio to see whether or not this is outside of that. Some people do a 10% rule. I'm not going to do it here, but the idea is that it's good to just have an idea of how different you want, because there's no specific test at this point. Another skill set that you should just put in your pocket as you're doing this is the ability to actually map the information that you get from doing these 2x2 tables onto the actual triangle. So don't be afraid to just in the margins of whatever you're doing start to actually do this kind of association so that you can convince yourself one way or the other whether or not you've got a confounder.